Unit 4, Quadrilaterals and Polygons, Lesson 1, Polygons and Symmetry. Your objectives for this lesson are to determine the measure of interior and exterior angles of a regular polygon, as well as to determine whether a figure has line symmetry or rotational symmetry. First of all, let's start off with defining what a polygon actually is. So a polygon is a closed figure, so closed with flat sides. A few examples of polygons are these. So, and you can probably identify these. This one is a pentagon. This would be a square, although it's been turned, and this is a rectangle. Triangles, which we've also been studying, are also polygons. What isn't a polygon would be something like this. So, because it's not closed, you have this open edge, that's not a polygon. And a circle is also not a polygon because it has curved edges and not flat edges. Okay, the polygon interior angle sum theorem. It's a lot of words. The important thing for you to know, though, is what this says. So the sum of the interior angle measures of an n-sided convex polygon is 180 times n minus 2. And you can take this one step further. The measure of each interior angle is 180 times n minus 2 divided by n. So, for instance, if I had a regular triangle, so an equilateral triangle, because we're talking about regular polygons, that means that each angle is the same measure. N is the number of sides, so that would be a 3 here. If I said 180 times 3 minus 2 divided by 3, I can simplify this. 3 minus 2 is 1. So I get, well, 180 times 1 is just 180. That's how many degrees are in a triangle. You already know that. Divided by 3 sides means that each angle is 60 degrees. Okay, so that's all that is there. But, oh, sorry, one more thing. But this does work for all regular polygons, so not just triangles. So if I had a 20-sided regular polygon, then this formula will work to give me the measure of each interior angle. The polygon exterior angle sum theorem tells us that the sum of the exterior angle measures of a convex polygon is 360. Always. So this is always how many degrees are in the exterior angle measures. If you wanted to just get one exterior angle, then you're going to divide by n, which is the number of sides. So again, if we were looking at a triangle, I would plug in a 3 for my n. 360 divided by 3 is 120. And again, this makes sense. If I have my equilateral triangle here, I know that the exterior angle, I'm just going to extend one of these sides. And if this was 60, 180 minus 60 is 120 degrees. These do have to add to 180 because it's a straight line. So this makes sense. Okay, example 1. A convex polygon has 13 sides. Find the sum of the measures of the interior angles. So we're going to use our interior angle sum theorem, and I know that the sum of my interior angles is n minus 2, so number of sides minus 2, times 180 degrees. So n is 13. Going to plug that in. So 180 times 13 minus 2. 13 minus 2 is 11. So really I just have 180 times 11. And pulling out my calculator here, I get 1980 degrees. So this is 1980 degrees total. Example 2, the measure of an interior angle of a regular polygon is 120 degrees. Find the number of sides. So here we have one angle in our regular polygon. So all the angles are the same measure. So I'm using this formula. Well, this would be the sum of all the angles, but we've divided by n to get 120. I want to find the number of sides, which means find n. That's our only variable here, so that's what we're looking for. And what I'm going to do is solve by cross multiplying. So I'm going to put 120 over 1 and cross multiply. So I get 120 times n equals, well, anything times 1 is itself, so I'm just going to leave this as 180 times n minus 2. Now, I want to get all my n's on one side, so I need to distribute 180 to the two terms in parentheses, and I get 180n minus 360. This is 120n. I'm going to leave 360 over here since it's the only term without a variable, and subtract 180n from both sides. On the right, that cancels. On the left, I have negative 60n, so equals negative 360. Last step in getting n by itself, divide by negative 60. And you see n equals 6. So that tells me that I have 6 sides. This is a hexagon. That would be my answer. Example 3, find the measure of each exterior angle of regular hexagon A, B, C, D, E, F. So you see we do have a hexagon. There are 1, 2, 3, 4, 5, 6 sides. And I'm looking for what each of these equal. Now, I know that there are 360 degrees total available for my exterior angles. If I divide by n, that will give me the measure of each of them. So that's what I'm going to do. So 360 divided by 6 sides is 60 degrees. So each exterior angle is 60 degrees. Okay, next up, changing gears a little bit here, talking about line symmetry. A figure can be reflected across a line so that the image coincides with the pre-image. So basically line symmetry, you can see my dotted line here. This is my line of symmetry. You have line symmetry when you can fold your picture in half and it overlaps completely perfectly. So it is basically a reflection across the line of symmetry, if you want to think of it that way. Okay. Does the shape have line symmetry? So is there anywhere that I could fold this in half and it would be a perfect reflection? And the answer is yes. So you may have guessed I could fold it here in half. I could also fold it this way in half. So there are 2 lines of symmetry for this rectangle. So my answer is yes. Next, This is an isosceles trapezoid, and you may notice if I tried to fold it, I guess hamburger way, this way, that's not going to work. So this corner is going to end up over here. We want it to be over here. That's just not going to work. So we can, however, fold it in half this way, so side to side, and that will be a good line of symmetry. So this one is a yes, although we only have one line of symmetry for this trapezoid. Okay, next, this is a parallelogram, and if I try to fold it this way in half, I'm going to end up with something like this. We can look at this in class. So that's not going to work. If I try to, so that's a no-go. If I try to fold it this way in half, same thing. That's not even in half. I can't fold it across diagonally. Basically, a parallelogram like this does not have a line of symmetry. So there are some special parallelograms like a rectangle that do, but this parallelogram does not have a line of symmetry. Okay, rotational symmetry. A figure can be rotated about an angle greater than 0 degrees but less than or equal to 180 degrees so that the image coincides with the pre-image. So we're looking at angles. Again, the angle of rotational symmetry is the smallest angle that maps a figure onto itself. Instead of drawing lines of symmetry, what we're doing here is actually twirling. So if I traced my X here and then I rotated my tracing paper 90 degrees, I would be, oh gosh, right about here. And you can see that doesn't really overlap. But if I kept going right there, it's like there's only one image. So I've rotated 180 degrees. My green dot went from the top to the bottom, so that's 180 degrees. And the figure has been rotated onto itself. So that is rotational symmetry. It's when you rotate something and you get the same image again. Okay. Does the shape have rotational symmetry? RA. So I already have the image here. And if I rotate it, we're going to watch where the green dot goes, okay? When it overlaps. So not overlapping, definitely not overlapping. Nope, 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 nope. Okay, but down here, it looks like I only have one rectangle. Where's the green dot? It's on the bottom. Before it was on the top. So I went halfway around to where I started from, which means I've rotated 180 degrees. So this is yes, has a rotational symmetry of 180 degrees. Part B. Does this one have rotational symmetry? Okay, so I have my green dot up top. Let's watch and see what happens. So this is not looking so great. Nope, not 180. Going, going, going. And okay, back where we started. So basically, I was able to rotate around 360 degrees before it overlapped again. But once you get to 360 degrees, you're at your original picture, and that doesn't count. So it has to be between 0 and 360. Since that didn't happen, this is a no. And it would appear that that is the end of this lesson.